always starts at the midline. Okay, on your y-axis, right? Because that's how you write the equation for a midline. And then the graph of cosine of x, the cosine function, is either above the midline or it's below if you have a negative at the very beginning, if it's being reflected. So if it's being reflected, it's going to be below, right? Because you reflect over the x-axis. But the graph of sine always starts on the midline, whether it's reflected or not. Okay? So I just want you to remember that in your brain. That's important. And that'll help you look at graphs. And if you can look at a graph and kind of split your hand across the function and find the midline, you automatically know if it's a sine or a cosine function. Okay. So for this first example, we are, so today we're just going to talk about periodic functions or periods and frequency of a function. So this first graph that you see that's already graphed for you, this is the graph y equals 3 times the cosine of x. That's what this says right here. So let's just first of all talk about, what do you notice about this graph? What are some things that you notice?
The midline is 0.
The midline is y equals 0. Yeah. I agree. Perfect.
It has an amplitude of 3.
Yeah, it has an amplitude of 3. I agree. Remember that amplitude is this measurement right here. Whether it's above the axis or below the axis, it's that vertical. Okay. We know it's a cosine function because it says y equals 3 cosine x, but where does it start? Does it start above the midline or below the midline? It starts above the midline. So that's another reason that we know it's a cosine function. So we're going to use Desmos, and I'm just going to project it for you so you guys don't have to pull up Desmos. You can use your graphing calculator if you want, but I think it's hard to see it on there. That's just because I have old lady eyes, I guess. But we are going to sketch the graph of y equals 3 times the cosine of 2x. We're going to put it right here on this axis. So I'm going to go to Desmos. I'm just going to kind of split our screen. And I'm going to pull up our graph. So the function that you see right now is y equals 3 cosine of x. We're going to change that to y equals 3 cosine of 2x. And I'm going to stretch it out because I know it's a little crazy looking right now. And I want to talk about what's happening. So I'm just going to set this so you can see what happens from, I just want you to look at what is happening in between 0 and 2 pi. What is happening in between 0 and 2 pi? Okay. Well, the blue graph is the function y equals 3 times the cosine of x. So if I were to just trace over this blue graph, and I know it goes off the page a little bit, but if I were to trace over this, I would see that it takes 2 pi for us to get through one whole cycle. It takes 2 pi for us to get through one whole cycle. But when I look at the green graph, the one that I just graphed, how many cycles fit into 2 pi? Well, I go down and come back up. That's one cycle. And I go down and come back up. That's 2 cycles. So 2 cycles fit in here. So that means that this number tells you what? If 2 cycles fit in this, that means that this number tells you how many cycles fit in every 2 pi, right? So that's the same thing as saying the frequency. This is the frequency. So I'm going to erase this and make it big, and we're just going to sketch this graph. So you guys are just going to copy this graph onto your packet. And I'm going to make it big so you can see what happens from negative 2 pi to positive 2 pi. So you're just going to sketch this graph. You want to sketch it from negative 2 pi to positive 2 pi. And you're sketching the green graph. So let me just get rid of the blue one so you don't make any mistakes. So this is what you're sketching. You are sketching 3 cosine of 2x. 3 times the cosine of 2x. And I'll draw that in our graph as well. So things that I want you to notice. You begin at the same spot, but instead of crossing the midline at the half mark, you cross it at the quarter mark. So everything happens in quarters instead of in halves. All of your moves happen in quarters instead of halves. Throw your hand up when you're done with that sketch, and I'm going to show you how I sketch it out on a. Thanks, Keegan. Who else needs more time? Raise your hand if you want more time. Okay, so I'm going to sketch it. I'm going to show you how I sketch it. So I just said that each one of these movements, like this crosses at a half, right? These are halves. So you start at the same spot, but now it's going to happen at a quarter. And then it's going to happen at a quarter. So let's see, I go down, cross through, down. Now I'm going to start working my way back up at the quarter. And then I go up, and then I come down at the quarter. So now I'm on the 0 or the midline, down, up, back again where I started. So when I look at my negative 2 pi, to 0, I have 2 cycles on that side. And then I'm going to do the same thing on the other side. So it's happening that those movements are taking place at every quarter instead of every half pi, every quarter pi instead of every half pi. So when I look at 0 to positive 2 pi, so this right here is one cycle of that function, 3 cosine 2x. This is one cycle. When we talk about the period, the word period means how many cycles fit in a 2 pi. So this is the horizontal distance of 2 pi. How many cycles of that green graph fit in there? How many cycles fit in that 2 pi? 2 of them. Look, I go down and then I come back up. That's one cycle. I go down and I come back up. That's 2 cycles. So we've sketched the graph, and the question B says, how many full cycles or periods of this function now fit within 2 pi radians? 2 cycles. That's the same thing as the frequency, which is this number right there. That's where that 2 comes in, okay? Are you guys okay with that? So let's talk about example C. Example C says, using your calculator, sketch the graph of 3 cosine of half x on the same axes. So let's just talk about what you think is going to happen first. What do you guys think is going to happen? Compared to the black, you're comparing to the black graph. How many, so if one full period, one full 2 pi is 1 cosine, what is half of, what's going to happen if I multiply by 1/2? How much am I going to get completed in there?
1/2 is like.
Yeah, I'm only going to be able to do half a cycle. Yeah, so let's think about what that looks like. So we're going to start at the same point, but instead of doing everything at 1/2 of a pi, I'm going to make that move. So if I look at the black graph, it starts up at the top at 3, and then it crosses the midline, or is at 0 at pi over 2. Well, now it's not going to cross the midline or the 0 until pi. And then it at pi, it's at -3, but that's not going to happen until 2 pi. And then I'm going to go on the opposite direction. So instead of being at the midline again at -1/2 pi, it's not going to be at the midline until -pi. And then instead of being at -3 at -pi, it's not going to be at -3 until -2 pi. So I've taken this graph and I've stretched this way out. I just stretched it way out like that. So this is y equals 3 times the cosine of 1/2 x. So it says how many full cycles or periods of this function fit within 2 pi? Well, we only get half of it. We only get 1/2 of a cycle. 1/2 of a cycle. I'm going to leave that there so everybody can graph it, and you just tell me when you're ready for me to sneak on to the next one. Does anyone want to see it in Desmos? Is it easier for you to sketch it off of Desmos?
No.
So I'll put no. Okay. Do you want me to just put one of them on Desmos, like just do the 1/2 cosine, or like one? I'm going to freeze this. What do you need, sir? Say again. Are you sure? Okay, yeah, just go. I'm gonna just put. I'm just gonna do the 1/2 of x. So I'm just gonna do that cycle, and I'm just gonna show you what that looks like. I've deleted the other graph. So you're graphing from -2 pi to +2 pi. You're graphing from -2 pi to +2 pi. So here's what I want you to think about. You start right here, and the original function crossed at the halves. Now you're not going to cross till a whole. So then you have to go all the way down to 3, but you're not going to do that till you get to the next whole, right? Full pi. So you start at 3, you go to 0 or the midline at whole pi, and then you go to -3. So this is just doing half of your function. And on the other side, you go from 3 to 0 or your midline at -pi. You have to drop back down to your minimum, which is at -2 pi. So minimum, this is at -2 pi, -3. This is the ordered pair -pi, 0. This is the ordered pair 0, 3. This is the ordered pair of pi, 0, God bless you. And then this is the ordered pair 2 pi, -3. Those are the points that you're plotting on your graph. And then just connect them with a nice curve. We good with that? Okay. Okay, so a period or a wavelength of a sinusoidal function is an important concept. It's defined as the minimum horizontal shift needed for the function to repeat its pattern. So it's the minimum amount of space, horizontal distance needed for the function to repeat its pattern. So we're going to look at those functions. Remember that A is our period and C tells us where our midline is. Well, B, this number right here, is representing our frequency, which I said early is the number of cycles that appear in 2 pi. It's the number of times the function pattern repeats in a 2 pi. Okay? So we're going to look at the graphs from above, and we're just going to fill this out. So when I looked at y equals 3 times the cosine of x, the frequency of that graph, the frequency of that function is 1, because there's no number attached here, no coefficient, right? So the frequency is 1. And we know that every period is what? How often do they repeat themselves? Like a typical function? A period, what's our whole all the way around the circle or the entire unit circle? A 2 pi. So we get 1 complete cycle in 2 pi. But when I changed that coefficient to a 2, my frequency became, oh, not B, so sorry. My frequency became 2. My frequency became 2. And when I think about that, how many cycles, how many whole cycles were completed in the, how many full cycles or periods completed in that 1/2? Do we remember? Well, we were able to complete 1 cycle. Okay. So that meant that we were able to get 1 pi. Yeah. And then if I look at the 3 to the 1/2, well, my frequency is 1/2. And that means that my period was what? How many times?
4 pi.
Yeah, it took 4 pi for us to get 1. It took 4 pi for us to get 1 whole cycle in. So a normal, like normal with no frequency, takes 2 pi. When I multiply by 2, we were able to get 1 complete cycle in 1 pi. When I multiplied by 1/2, we were able to get 1 complete cycle done in 4 pi. So I'm waiting for you guys to get that down, because something cool really happens with that. Okay. So here it says clearly we can see that the frequency and the period are inversely related. So let's talk about the relationship, hopefully. So when B, which is my frequency, and P, which is my period, when we talk about that, hopefully you notice that the product, this is what it says right here, the product of the period and the frequency always equal what? Okay, well, let's look back. I'm going to just go back. The product of the period and the frequency, the product of the period and the frequency. What is 2 pi times 1? 2 pi. What is 2 times 1 pi? 2 pi. the period 4 pi times the frequency 1/2, what is half of 4 pi? 2 pi. So the product of the period and the frequency is always going to equal 2 pi. Yeah. And that's really cool. It's always going to equal 2 pi. So this is how I think about this. The period times the frequency equals 2 pi. That's really important. Like that's the superstar. But we know that we can like maybe I want to know the period and I only know the frequency. Well, that means that the period equals 2 pi divided by b, the frequency. Well, what if I want to know the frequency and I only know the period? Well, that means that the frequency equals 2 pi divided by the period. Because all of these mean the same thing, right? All three of these functions or all three of these equations, they just mean the same thing, right? The first one is the formula. P times B equals 2 pi. The second one, I just divided both sides by B. And the third one, I just divided both sides by P. You guys see that we did that, correct? Okay. So we need to know the period because that helps us think about how we are going to graph our functions, right? So let's look at exercise number 4A. It says y equals 6 times the sine of 4x. Y equals 6 times the sine of 4x. So my frequency is what? My frequency is 4. I need to figure out what the period is. Okay, so let's think about that. I know that the period times the frequency equals 2 pi. I know that my frequency is 4. So if I divide both sides by 4, I find out that the period is, let's see, 2/4 is the same thing as what? Pi over 2, yeah. So my period is pi over 2. And we know that from the example before when we put a 1/2, we said that when we had a 1/2 out there, we knew that it took 4 times, right? So let's look at this one. What is my frequency? It's pi over 3. So let's see, I know that the period times the frequency has to equal 2 pi. So the period times the frequency, which is pi over 3, has to equal 2 pi. How do I get rid of this fractional coefficient? Multiply by the reciprocal. I'm going to multiply this side by 3 pi, and I'm going to multiply this side by 3 pi. The pi's cancel out, the 3's cancel out, so P equals, well here, this is like 2 pi over 1, so the pi's cancel out, and I'm left with 2 times 3, which is 6. Okay, what is the frequency in example C? What is it? Yeah, 2 over 3. So let's see. Period times the frequency equals 2 pi. So the period times 2 over 3 has to equal 2 pi. I need to get rid of that fraction, so I'm going to multiply both sides by the coefficient, 3/2. Multiply both sides by the coefficient reciprocal, 3/2, right? So P equals what? The 2's cancel out, but the 3 and the pi stay. You see that? So P equals 3 pi. We're just doing some basic algebra. If you don't like working with fractions, you can turn those, like you can use your calculator. Just make sure you're real specific when you use your calculator because you're going to get repeating decimals if you turn them into decimals. Okay, So we're going to look at this function right here, y equals 2 times the sine of 4x. And we're going to write down all the things that we know before we even try to sketch it. So let's see. Y equals 2 times the sine of 4x. So what's one thing that you notice or you know? The number in the parentheses is 4. So that means my frequency is 4, yeah? So if my frequency is 4, can I figure out the period? So the period is 2 pi divided by 4, which is pi over 2. Okay. What else do we know? The amplitude is 2. Yeah. Okay. Where is the midline? Does this have a vertical shift? Yeah. Y equals 0 is my midline. Okay. I think that we have everything we need to know to graph this, except we don't know how to number our axes here. So I want to talk about this right here. This means that we will get one complete cycle in a half of pi, right? Means that we'll get one whole complete cycle of this function in half of pi, in that horizontal distance of half of pi. And when you think about your graphs, we said that trig functions are graphed in quarters, right? Just like the quadrants, right? So if you think about it, like your circle moves around in a quadrant, but your graph, when you think about it as a trig graph, it could go up and then come down, or it starts up here and goes like this. But either way, this is happening in quarters. It's happening in quarters. So I need to figure out what 1/4 of pi over 2 is, because that'll tell me how to number my axes. So I need to figure out what 1/4 of pi over 2 is, and that'll tell me how to number my x-axis. So I have to break this up into fourths. So what is 1/4 of pi over 2? Well, of means multiply. So 1 times pi is pi, and 4 times 2 is 8. So we're going to start at 0, and our first position is going to be pi over 8. And then our next one is going to be 2 pi over 8, which is the same thing as what? 2 pi over 8 is the same thing as pi over 4, yes. And then the next one is going to be 3 pi over 8. 3 pi over 8. And that can't be reduced. So 3 pi over 8. And then the next one is 4 pi over 8, which is the same thing as 4 pi over 8 reduces to pi over 2. Do you see that? And now we just take those numbers and we work backwards on the other side of the y-axis. So negative pi over 8. This is pi over 4, sorry. Negative pi over 4, negative 3 pi over 8, and negative pi over 2. Okay, so we know it's going to have an amplitude of what? 2. And it's a sine function. What do we know about sine functions? Where do they start? They start on the midline. So, which is y equals 0. So I'm going to start on the midline. And sine is representing, like, remember with sine we go up and then we come back down. Do you guys feel like you can? I feel like we should be able to maybe do these in our sleep. So how high up does this go? This has an amplitude of what? So the first quarter, I'm going to go all the way up to 2. So pi over 8 is going to give me an output of 2. And then, so I come up, and then what do? I come back down. So I'm at the midline at pi over 4. And then for 3 pi over 8, I'm going to dip down to negative 2. And then I'm going to come back up to the midline. So this is the right side of my graph. Okay, so now let's do the negative side. So same idea, right? So I need to go down to negative 2, back up to the midline, up to positive 2, back down. Because all I'm doing is just repeating this pattern. So this is one cycle right here. And this is another cycle. You just keep repeating that. So I think the only thing that's really tricky is this whole part right here, figuring out how to number your x-axes. What do you guys think? Hello, are you awake? Is that okay? Do you feel like you're okay with that? Yeah. You take the period and just divide it by 4 or multiply by 1/4. That's all you're doing. Perfect. Okay, last one. It says the height of the tides can be described using a sinusoidal model in the form A times the cosine of bx plus c. So remember, this is your amplitude. This is your frequency. And this is your midline. Okay. If high tides are separated by 24 hours, which of the following gives the frequency? So we're trying to find B. High tides are separated by 24 hours, meaning it starts up high, comes down low, and then goes back up high. Okay? So this represents a period, and it takes 24 hours for that to happen. So my period is 24. I'm trying to figure out what my frequency is. How am I going to do that? 2 pi divided by 24. So I'm going to share your thinking. Remember that we said that the period times the frequency is always going to equal 2 pi. You know that your period is 24, so 24 times b equals 2 pi. And then we'll just divide both sides by 24. And that reduces to pi over 12. Yeah. So what choice is that? 3. What kind of a function is that? Cosine, right? Starts up high, goes down low, starts up high. Okay, that's it. That's what I've got for you.